let's have a look at another example involving linear modeling. Okay, so this is an example that models a financial situation. So let's go through the situation together. A loan is to be repaid over time in fixed installments. After 6 months, there was $31,500 owing, and after 14 months, there was $17,500 owing. So part A is find the equation of the line that represents the linear relationship between the amount owed A dollars at time t, where t is in months. Part B, what does the gradient and the y-intercept represent? And part C, after how many months will the loan be repaid in full? So I'm just going to answer or do the work solution, on a separate board. So I've just run out of space. Okay, so to find the equation of the line, we need 2 points. Okay, and we do have 2 points, in fact. Okay, I'll just go back to the original example, to the wording there, the worded problem. So we have at the 6 month mark, the amount owing is $31,500. So that's actually 1 point. Okay, so at the 6 month mark, we have $31,500 owing. Okay, and at the 14 month mark, there was $17,500 owing. Okay, so 14 month mark, there was $17,500 owing. Now, can we find the equation of the line that passes through these 2 points? Okay, and of course we can. We need the gradient, we need the y-intercept, because we're going to express the equation of the line in the form y equals mx plus c. Okay, but we're not going to use x and y, we're going to use a and t, of course, so as our variables instead of y and x. All right, first things first though, we do need the gradient, so that's going to be y2 minus y1 over x2 minus x1. We can still use the formula as is, we've just got to label these 2 points. So I'm going to label this one as x2 y2 and this one as x1 y1. And I'm just going to substitute in these points. Okay, so y2 minus y1, so 17,500 minus 31,500 over 14 minus 6. So that's x2 minus x1. Okay, and we get negative 1,750. Now we need the y-intercept, okay, or the vertical intercept. In fact, let's use the correct or the better terminology. So look, you're not going to necessarily get it wrong by writing that, but let's call it the vertical intercept. Okay, only because we're using the letter A instead of the letter Y. But apart from that, it's the same thing what we're going to do. So we're going to use y equals mx plus c. Okay, of course, but we're not going. I'm just going to replace the pronumerals. Okay, so a is equal to mt plus c. Okay, now we can pick any of these 2 points. Okay, so whichever one, doesn't really matter. You're going to get the same result anyway. So we can pick point number 1. So when a is equal to 31,500, okay, t is at the 6 month mark, and we have a value for m, which is negative 1,750. Okay, times 6 plus c. Now we need to solve this equation for this c, which is the vertical intercept. All right, so let's do that. Okay, so 31,500 is equal to, if we just type this in, so times 6, I'll just show you what I'm doing there. Okay, which is negative 10,500 plus c. Rearranging this formula to making c the subject of the formula. Okay, so 31,500 plus 10,500 is equal to c. Okay, and so therefore c is equal to 42,000. Okay, so how would we write the equation? Okay, the equation of the line that represents this relationship is a, okay, is equal to negative 1,750 t plus 42,000. All right, so that's part A. What about part B? Part B asks what does and we'll just put the question back, okay? What does the gradient and the y-intercept represent? Okay. The gradient basically represents the monthly payment, okay, which is $1,750. So we're paying down the loan, okay, and that we're paying it down at the rate of $1,750 per month. Okay, so the gradient, okay, represents the monthly payment of $1,750 per month. Okay, so it represents the gradual sort of paying back of the loan. What about the y-intercept of 42,000? Okay, so a y-intercept occurs when t is 0. Okay, so when t is equal to 0, this is the y-intercept of 42,000. This would be the original loan amount. Okay, so that's answering part B. Okay, apologies that I've actually had to put it on one side of the board. Again, I'm quite short on real estate here. So that's part B. So gradient and y-intercept, okay, it represents the original loan amount. So what about part C? After how many months will the loan be repaid in full? Okay, so there's the final part there. So I guess the question is, when the loan is repaid in full, what is the value of A? Okay, so I'm just going to rub this board out. Okay, just going to keep the equation of the line. Okay, so while you're having a think about it, okay, we've got A is equal to negative 1750t plus 42,000. Okay, so when the loan is repaid in full, right, A is equal to 0. And we're going to find the value of t when A equals 0. All right, so let's do that. 0 is equal to negative 1750t plus 42,000. We're going to move the negative 1750t over the other side. It becomes positive. So 1750t is equal to 42,000. And we're going to divide both sides by 1750. So in fact, the net effect of that, all we'll have to do is divide 42,000 by 1,750. Okay, so let's do that. So 42000 over 1750, and we get 24. Okay, so what does this mean? Time, remember, is in months. Okay, so loan is repaid in 24 months. And that's it.